One of the biggest disadvantages of using the Voronoi technique to fracture geometry is its very distinctive and geometric patterns. Usually, the Voronoi pieces are very distinguishable and usually are very unnatural since they are almost perfectly geometrical. And they may be useful for certain applications. Maybe you're doing some crystal shards, or probably you're doing some abstract animations, and they will be fine. But in most of the cases, when you're creating destruction, you want to break this Voronoi look. And there are several techniques that we can use to do this. One of the most common and the most simple technique is the clustering technique. And by clustering, I mean by grouping several small pieces into larger chunks. So let's create a practical exercise. For now, I will be using this model from Quixel Megascans. Unfortunately, I will be unable to distribute the model with the file, but you can use any other model that you have, or you can even use simple geometry. In this case, I have added a switch node that can be switched into a box with the same dimensions of the wall. But for practicing purposes, you can use any model. Just make sure that it's a watertight model. Okay, so let's start by adding a scatter node. So I have a null here labeled out geo, just to easily know that here we will start fracturing. And I will connect, first of all, an ISO offset to create a volume from the model. And I can increase the resolution. Let's increase it to 60. And let's scatter some points. So remember, sometimes when you are using many points, or maybe when you want a more uneven result, you can turn off the relax iterations. So this will give a more random distribution of points. And then I will connect a Voronoi node into the main tree. I will connect the scattered points into the second input of the Voronoi fracture. And let's click on the Voronoi fracture to make it visible. Now, the Voronoi cells have been created. I will connect an exploded view just to make it more clear. And here you can see the pieces. So we have quite a few pieces. It's fine. I think the computer should be able to handle this very quickly. But the problem is that if you have a closer look, we have these very sharp edges, very linear edges, that, as I mentioned before, are kind of unnatural, especially for something like concrete or brick or mortar. So let's try to break up the contours of these fragments with a clustering technique. So let me zoom out a bit, and I will look for a node called RBD cluster, and I will connect this node just below the Voronoi fracture. Now notice how we have a second input called constraints, and even though we won't be generating constraints in this exercise, we will be touching on constraints in later tutorials, we will need to connect this input for the clustering workflow that I will be using. So let's click on the RBD cluster node, and let's take a look at its parameters. So first of all, we have the cluster name prefix, and here I want to show you, I will go into the geometry spreadsheet and into the primitives area, and notice how the name has been changed to cluster. So remember, with the Voronoi node, you get an attribute called name, and the Voronoi by default uses the prefix piece. So we have piece 0, piece 1, etc. Now, when we added the RBD cluster, this name attribute has been changed to cluster and a number suffix. In this case, it also created a cluster attribute. So it's a separate attribute, and the name has changed. Just keep that in mind. So I will go back to my scene view, and in the RBD cluster, I'm going to click here on the cluster attribute. To the right, we have this icon that will let us visualize the clusters that are being generated. So let me connect the exploded view here to the RBD cluster node and take a look at what's happening. So notice how now we have a few very big chunks and very small pieces that they don't look very nice. They look better than what we had, but let's try to fix this and try to get a nicer shape. So first of all, I'm going to look at the detach ratio, and this is what's creating the small little pieces, like the separate cells. So if I bring this value down to 0, I will only have the big clusters of pieces. So for now, let's leave this parameter at 0, and let's use the cluster noise parameters to change the shape of these pieces. So first of all, if we change the size, if we increase the size, we will have larger pieces. If we reduce the size, we will start getting much smaller pieces. So this is starting to look very good. It's starting to look much more natural. Say, for example, that I'm happy with the size of the pieces, but maybe I want to change a few of these shapes. I could offset the pieces to get a different result. Actually, I think I'm going to go with a larger piece. I'm going to offset it a bit. Probably like this. And I want to show you now the detach parameter that we used earlier. So say I want a few smaller pieces detaching, then I could increase this ratio just to have a few. And if I'm not happy with the pieces that were created, I can always change the detach seed. By itself, the RBD clustering node can be very useful, but its main advantage resides in the fact that you can create your own clusters. Say, for example, that you want very specific shapes. You can create those shapes based on selections of points. Let's try that next. I will make some space below my Voronoi node, and I will create a null object and connect it to the second input of the Voronoi. And just for you to see, these are the constraints that are being created by the Voronoi fracture. But for now, let's ignore the constraints and let's worry about the clustering. So I will add a new point wrangler just below my null. So first of all, I will create on this arrow button to the right. This will let me make a selection of points. So make sure you have this lasso select and create an irregular selection, say on the top right corner of the wall. Then press enter to accept this selection. And now notice here under the group of points, this point wrangler will run over the selection we just created. So let's type this, I at cluster. So cluster is an attribute that Houdini will recognize, and it's an integer. And this can be any number. For now, I will just use 1. And don't forget to type semicolon. And every number that you use for the cluster will be a different piece. You can have as many clusters as you want, as long as they have different numbers. So let's try connecting this wrangler to the second input of the RBD cluster node. And notice how now the clusters that we had have been overwritten by the ones that I've just created with a point wrangler. And notice how this cluster noise, by default, it says preserve existing cluster. So this means if there's a cluster attribute down the line, whatever clusters are being generated here in the node will be ignored. So let's try changing this to override clusters. So now it's ignoring the ones that I've just created and generating its own. Now notice we also still have on the random detach option. I will turn it off. And this way, when I use the clusters I created, I will only have those two pieces. Let's try creating another corner piece. So I will copy this wrangler. Maybe we can rename it to create cluster 1. So I will copy it, paste it, and connect it here on this branch. I will generate a new selection of points. And press enter. Now I will change its name to cluster 2. Press Ctrl enter. And now I have my new piece. So as you can imagine, this will let us create very unique and customized pieces.